This lecture we will see how to design it, the structure. Okay. So one thing more I forgot to tell you, if you want to also add that if you are applying the seismic analysis for the building, okay, make sure that you have also applied the reduction factor, okay, so that will help you to generate more economical structure to you, okay. Property reduction factor, ठीक है? Okay, so for beam our code says to you 1897, if you 1893 code refer you, if you for column you use zero point 0.7 in both directions, okay. Moment of inertia value, so add, and for beam we'll use 0.35. Okay, this was actually written in code. Let's check it on this time. So if you see here, okay, here if you see, so on page number 14 of IS 1893 2016 part 1, for structure the moment of inertia will be taken for RC imaginary structure 70% of I graph of column and 35% for I graph of beam, and for steel structure we will take a total percent, okay. So 70% for column and 35% of beam for RC structures. So here what we have taken, to 70% for column, go to select parallel to y-axis, so we should assign in all the columns, okay. This is the most reliable practice for engineers to provide the um, uh, moment of inertia as per course code suggested. So building will be more economical and the size of beam and column will be more compact to design, okay. Otherwise, due to crack section the sizes will be increased if you do not add these values, okay. So please provide these value reduction factors. Select a beam parallel to X, select beam parallel to Z, assign to selected, okay, we all assigned it. Now we go to loads again, okay. So these values has been added here, okay. Okay, let's check it once a time, okay. After that we will go for design. Error, okay, error 0 and warning 7 है, तो check करते हैं okay. We'll check it. Math model, okay, no problem. Mass define analysis, see here. Now the base shear from this point is led, so base shear is calculated right now, okay. In previous lecture it was not calculating, that px and pz value was not present, it was software was showing, but right now it is calculated because I already uh, uploaded a value manually through the formula. So you can check my previous video, so you can get what was going here right now. So this value will, right now it is coming, okay, base shear calculated. So here the multiplication factor, the software will automatically generate these time period of factor, okay. So we should multiply this factor uh, to just overcome the value as 1. So this value will be always 1 or nearby 1, okay. So this value is calculated by the software empirical formula, by the code empirical formula, and by the response spectrum. So the both ratio is coming as 8.29. So these multiplication factor should be multiplied to the given x and y that was we have manually inserted in x and z direction. So what should I, this is for x direction, okay. So what should you do, it was coming at 8.3, assume it as 8.3, and For Z direction it was coming as 7.8. So what should we do right now? Go to RSX spectrum. So in this value, okay, 8.3 will be multiplied. So 0.01016. Okay, so 8.3 will multiply by 0.016. Okay, so what value will come? 0.133. Okay, 133. Change. And for Z direction, what value is factor is coming? Around 7 7.8 it was coming. Okay, so multiplied by this value, so 7.8 multiplied by 0.016, so the value will be 0.1248. 1248. So change, close, analyze, run, analyze, save. Okay, always remember to use this factor in this formula. Okay, so let's check what right now what is coming. Okay, still the factor, maybe I've given the wrong value for this. See, for Z it was coming around nearby 1, so that was okay, but still the 4.02, maybe I given the wrong value here. Okay, so in this you have to multiply how much, 8.3 is coming at that time, so the value will be 0.1328. Okay, I've written wrong, 328, sorry, 1328. Okay, let's change the value and close. Let's check right now. So for Z it is coming base shear fundamental. Okay, there is something mistake in this value. So 0.016. Let again go with the 0.016 value. That what we had provided at the starting phase. Analyze, run, analyze, save. This is one of the important steps when you are going for spec. Remember that. Okay, it is 8.3. So we should multiply that with 8.3. So 132.1328. So let's see, 1328, close. So okay, zone parameter value is not matching. Okay, we will check it with code only. Okay, in Z direction it was okay, that was not a problem. So all the SA by G value is 2.5 and our time period is calculated 0.17. Okay, every value is right now it was okay, so it is calculated, but in X direction it was not matching, so we can 0.16. we can again check it once more time because the value should be matched by the software and what we have given. Okay, 8.3 and 1.08. So base share is less than, so 8.3 value is coming right now. So that is too much. Like a value is okay. Here actually I changed this value, zone value. That's why it was saying me that zone value was not matching. Okay, I'm going with third one, and right now maybe at that time I am using the ordinary. Let's go right. Okay, we will see what happened right now. So I've changed that value by mistake. So it was showing me that that value is not matching because the x value that was calculated from that formula only. So if you follow the step by step, then everything will be okay. Right now the value for is coming around 1, so that is this is okay. Okay, so after that you can go for design procedure. Okay, if you want to add the combination, okay, let's add the combination. Okay, load case and detail add define combination. If you want to define it manually, okay, you can do it also from here by providing one by one, or if you want to auto load combination, you can go directly from here, general structure generate load. Okay, now for now when I am going directly from software added. Okay, so almost all the combination has been generated, there will be no problem. Analyze, run, analyze, save. So just check error is coming or not. If error was not coming, we will proceed further. Okay, no problem. So what we will do right now, go for design, select for concrete design. Okay, we are going to select our code as IS456. If we are going for ductile detailing, that we generally use in harder seismic zones. Okay, this move on third and fourth, where we are using multi-story building. So you use one IS 13920. This is used for ductile detailing, but for now I am going for normal detailing. So IS 456 select parameters. Here you can give the value according to by yourself what you want to arrange in beam and column, how you are going to collect it. Okay, so we are going to give the software the compressive strength of concrete, Fy main, Fy secondary the tension tensile strength for steel. Okay, if you want to give the maximum and minimum size of steel, you can also give by providing this, just maximum size of main reinforcement, maximum size of secondary reinforcement, main bar for combinations. So it will be more practical to you to use on site. Okay, if you define this value, so software will not go beyond value that what you have inserted here. Okay, if the value will come more, then it will show the beam was filled. Okay, beam or column was filled, so you can increase the size according to that. And if you don't want to put this value, then you can go simply but provide just providing compressive strength and the yield strength. Okay, so the percentage reinforcement tied spiral, so much option was given here. Just go further. So we are taking as M25 grade of concrete for structure, so take it 25,000. Okay, it is written in kilonewton per meter square, that's why I'm taking 25,000. So edit. After that you go for Fy main. So main information we are going to take as 500. Okay, kilonewton per meter, that's why I added 30 more. add fy secondary, take it as 415000. This is the general form of steel that we take in main and secondary beam or column. Okay, main and secondary bars. So maximum main. So what, how much size did you provide for the maximum? That is the main reinforcement for beam and column. You can go for it. See, I will provide up to 16 of maximum. Okay, so I will add it. Maximum secondary, how much you go for maximum? I will provide up to 10 Go for 8. Okay, go for 8. So MD1 main bar size for bar combination. So combination is if any in any beam or column you are providing 4 bars, so it will make the combination. So combination of 12 and combination of secondary main bar size for bar combination greater than MD1, so 16. Okay, so close. So we have to assign these value that we have given to the software. So if so it was assigned to whole structure, assign. Okay, fy main similarly going to whole structure, assign to view, assign secondary, same for whole structure, maximum main. So we are going for both beam and column. Okay, assign to whole structure, assign. If you want to assign by selecting, then you can go and select from here in y direction. So all column will be selected, then you have assigned to selected beam. Okay, so maximum secondary 8 in both beam and column, so are going to assign to view. MD1 combination, so we are doing same thing for every beam and column. Okay, you, if you don't want to do this, then you can go and by selecting every beam and column, whatever bar combination you want to provide, just select it and assign to selected beam. Okay, so we go for design, add beam, design column, add column, slab element, take off. Okay, so design element will not be there because we didn't provided any plate. Okay, design beam, so we go to select beam parallel to x, select beam pass. We have to tell to software that between these which are our beams. So you have to select the beam, and so these are going to design in beam. So that will be more easier for us to understand which is beam and column. So design column, assign to selected beam, assign. It was defined twice a time, so we will delete one. Okay, everything was okay right now. So we will go for analyze, run analyze, save. Let's check what the result will come. So you go for output. The warning will increases. So some modes, okay, no problem. Zone parameters, wall now value is not matching with the value. So what I value I have given in zone, seismic zone, actually that was not matching in my with my RSX that was given in load combination. So if you go step by step, that value will be same. Okay, I have changed by mistake. So x value will be calculated by 2 into I by r, so that value differ from the seismic value that we provided. So that's why it is showing it was not a big problem. We will correct it. The value of ss parameter not matching y, same thing was showing here. Zone parameter, so section failure. So those sections that are failing was been showing here. You can again check or increase the reinforcement. Okay, we can go for result concrete design, so beam. So those that were designed, this value was showing here, and for those that was not designed also, those were also showed here. So beam one is designed, okay, that was okay for. So 8 bar of 12 two layers. Okay, so it is showing here the corners part and the middle part, it was divided in 5 parts. Okay, That is a shear reinforcement. That is a stirrup, two leg of 8 dia at 90 mm center to center. Okay, two leg mean that was a ring type. That was square ring type. It was provided. Okay, so all the values was main reinforcement. All the value was given here. That was not a problem. Effective depth. Everything is here. See, unable to commit required reinforcement. Okay, so software is calculating according to what we have told to calculate us. That we have also given the minimum and maximum value. So that's why it was failing sometime. See here, it was 6 bar of 12 mm at top. See either here front elevation also showing. Okay, and in bottom it was showing 2 bar of 16. Okay, similarly you can check from here also. 6 bar 5 bar of 16 showing, so maximum we are given the 16 combination, that's why software is doing this, and 2 bar of 16 was showing. Okay, let's check the bottom one. Let's see, bottom one is failing. Okay, because more load have been carried to the bottom, so we will again redesign it. Okay, if you don't provide these values to the maximum and minimum, let's delete these values. Okay, MD. Okay, this we are given software an order to just make the combination of these bars. Okay, right now we have deleted that option. Okay, just check what software does now. We will go for output. Just close it right now. Go for check. See, now software is doing providing 20 of bar of three number. So now software is doing by itself. So that was also economical for you, because sometimes 40 or 20 or 30 bar was not generally not been seen in normal buildings or G+2 or G+3 building. Up to 16 they will carry. So, and it was easier to available also. So you can make that also. If you don't do that, then this will happen. More dia of bar will be provided here. In different beam, different dia will be provided. So that will be more difficult to calculate. If you provide the maximum minimum value, that will be more easier to you. Okay, you will get the answer, and those beam that was failing, just increase the depth or size. Okay, so they are going to pass. This is the column. Okay, so now I hope that you understand how to design the structure. Okay, so you can get this value. If you want to design the slab from this, okay, we can calculate it manually, or you can use the plate also. In upcoming lecture I will show you how to use the plate and just calculate the moment that was coming, moment, and how much, how to design it through how much of steel was coming for slab. You can also get from here, but you have to calculate it manually after that. Okay, if you are going with Indian analysis as per IS code. Okay, so if you use the plate, we can get the moment in slab and also the steel area that we are getting in every slab. Okay, so that we can calculate it manually after that through the area of steel. Okay, for now we are only calculated for beam and column, and I have applied all the loads to the building and structure, and also applied the seismic load as it is 9-meter building. Okay, if it is about 10 meter, we are going to analyze with wind load also. Okay, so in upcoming video I will also teach how to apply wind load. Okay, I have already uploaded the video in Hindi, so you can go and check if you understand. If you don't, then comment me. Okay, I will upload in English also. Okay. Okay guys, thank you. And remember, if you like my video, please subscribe my channel and like my video, and come click on bell icon so you can never miss any new video. Okay, in upcoming lecture will be working in Tekla and ETAB also. So we are going to see in both language, Hindi and English. Okay, thank you.